Welcome back for part 20 of this narrated series of videos that sit alongside my GCSE Science Sprints. Today's topic comes from Unit 3, which is the quantitative chemistry topic of AQA GCSE Chemistry or Combined Science. Now this is a reacting masses question, and I mention that because often these questions can seem really intimidating, but actually there are a few different types, and if you're able to identify at the start of a question which type it is, then they're often very formulaic, they follow a really similar pattern, and you know where you want to be going from here. So the first thing I would say with any of these quantitative questions is it's worth doing a little bit of housekeeping before you start. Don't just dive in. So in this symbol equation here, we have 4 different chemicals, but you're not going to need to use all of them in the question. And so it's easy to waste a lot of time working out the relative formula mass of something that isn't actually mentioned. So I would start off by getting really clear in your head which numbers apply to which chemicals and what you don't need to worry about. So the 180.9 goes here on the right hand side, and then it's the sodium hydroxide we're trying to work out, and the other 2 are completely irrelevant. So I would literally cross them out so that you're not suddenly starting to work out something with them and wasting time in the exam. Now, in basically every quantitative chemistry question, there are likely to be some marks for working out the number of moles of a substance. So even if you don't know how to get to the end of a question, you can spend some time working out moles, and that's usually worth a mark or 2. Now, there are a couple of different ways you can work out moles, depending on whether you have a solid or a solution or a gas, but usually for each question, you're only going to be given the set of information to work it out in one way, so you're not going to have to pick between them. Here we've been given mass data. We've got 180.9 grams. So we know that we're going to be using the masses Mr. Mole equation. So we have the mass, we want the moles, we need to work out the Mr, or the relative formula mass. So we do this by adding together the masses of all of the atoms that are in that compound. Sorry, it's quite small, it's because I'm trying to fit 2 of these next to each other on the same slide. So once I have that relative formula mass of 134 grams per mole, I can put that together with this masses Mr. Mole equation. So I need to rearrange it. So the number of moles is going to be the mass divided by the relative formula mass. So 180.9 divided by 134. And that's going to give me an answer of 1.35 moles. Now, I need to work out how many moles, therefore, I have of sodium hydroxide. And this is where I want to be looking at the coefficients in the symbol equation. So these are the big numbers that are in front of each chemical and tell me what ratio they come in. So this equation tells me that for every 1 of my product, I'm going to need 2 sodium hydroxides. Now, chemists are lazy and we don't write the number 1, and here you don't really need to use it, but I'm going to add it into my equation here, just because if you get a question with more complicated coefficients, then you then know what to do with them. So in order to work out my moles of sodium hydroxide, I'm going to divide by the moles of the thing I know. So here I've put in that 1. Chemists are lazy, we never write the number 1, but it's there really. So I divide by the coefficient in front of the thing I know, and I multiply by the coefficient in front of the thing I don't. So therefore I get 2.7 moles. Now, in order to work out the mass of sodium hydroxide, I need the MR of sodium hydroxide. So again, I'm going to find that by adding up the masses of the 3 different atoms that are in that compound. And remember here, the relative formula mass is always for 1 mole. It's defined as being for 1 mole. So don't fall into the trap of, I often see people here trying to work it out for 2 sodium hydroxide. We've already used that 2, that coefficient, for something else. We used it to show us how many moles there would be. This calculation is to work out what the mass of 1 mole would be. But we don't have 1 mole, we have 2.7 moles. So we now need to multiply that 40 that we just worked out by the 2.7 to give us a final mass of 108 grams, and that is my final answer. Thank you very much for watching, and I hope to see you back again on Friday for some more physics science sprints. If you have found this useful, then don't forget to like and subscribe for more GCSE Science revision videos coming soon.